I just switched recording on. Good morning, everyone. And as we have another lockdown, I think it's a great opportunity for us to consider a broader scope of issues related to systems modeling. Hopefully in a couple of weeks, we'll be back on campus and we'll start more mathematical parts of this course. So our first topic is systems perspective on technological progress. So modern theory of technological progress can be divided into three categories. The first one is routine. Technological progress is accumulation of many small steps, many incremental improvements of technology, which are usually driven by economic necessities. The second approach is heroic. Society is usually conservative, and there is a person, an inventor, which is in the center of technological progress. He has vision, he is creative, inventive, and he creates these new ideas, new approaches which change to the technology and move the society forward. And finally, we're going to look at and examine evolutionary approach to technological progress, which corresponds to systems perspective on this problem. And in this case, inventions are interpreted as systemic mutations of knowledge, of technological knowledge, which are subject to selection of the society. In general, I just need to know that economic or political analysis of technological development, technological progress, this kind of analysis are quite common, but it's not so often when technological progress is considered from the engineering perspective. It's a little bit strange because what's engineering is about? It's about development of technology. Still, we're going to use this perspective, engineering perspective on technological development, and that's what this lecture is dedicated to. The basis of evolutionary approach to technological development is a certain set of ideas which have been introduced by many prominent thinkers. But probably it was expressed by Richard Dawkins in the most articulate and direct way, and that's why we call it the Dawkins conjecture. This statement made by Dawkins first in his book, The Selfish Gene, and this statement indicates that evolutionary mechanisms are not unique to biological systems, as many people thought before this. Evolutionary mechanisms are general properties of complex systems with constrained replication of information. And physical nature of the system does not matter. This assumption, this hypothesis, is a remarkable system-based understanding of the physical world around us. It goes through different disciplines and determines the key issue which is related to evolutionary process, its replication of information. So we're going to follow this understanding and analyze technological process from this systems evolutionary perspective. All different forms of information can be divided into genetic forms and non-genetic forms. Genetic forms are related to biological evolution, and all other forms of evolution represent non-genetic forms of information. These forms can be and should be divided into cultural information and technological information. We are interested in technological information. So we are engineers, and development of technology, which is a process which surrounds technological information, is most important for us. So first of all, I just need to emphasize that information is not necessarily knowledge. When we speak about social information, It can be some useful ideas, or it can be some information which tend to propagate between people, and validity of this information is not important. What is important, whether this information can induce its further propagation in say, human society. Religion would be a good example of information which is very effective in propagating itself. Whether religion is valid or not is not most important issue for us. The same applies to technology. Technology is different from cultural information. Technological information is different from cultural information because technological information can be applied to surrounding physical world to produce some tangible positive results. Again, it's useful information, but it does not mean that this information is scientifically correct. It might be correct, might be not correct. So at this point, I want to emphasize we distinguish information and knowledge. And among all possible forms of non-genetic information, we divide these forms into two broad categories. One is cultural information, which cannot change the surrounding world. And another one is technological information, which can be used to change the world around us and effectively improve our lives. So the essence of Dawkins' conjecture is existence of broad similarity between technological evolution and biological evolution. In biological evolution, genes are replicated, they mutate, and then they're subject to natural selection. As similar processes occur with respect to technological information in human society. They're subject to invention, which play a role of mutations, and then several different layers of selection, intellectual selection, say managerial selection, and finally society might accept some innovation or not to accept. When society accepts or does not accept some innovation, it's not necessarily that society is wise. It might be conservative, it might be that these new ideas, which can be very useful, are not accepted because society simply is not ready. Sometimes inventions are premature, and later on they can be used in similar conditions quite effectively. So in any case, we have a similar process which resembles ours, biological evolution, but there are significant differences. Of course, no one would say that these two different types of evolution are exactly the same. Not at all. Of course, biological evolution produces life forms, and technological evolution doesn't. But this is not the only difference. Technological evolution overall is much more efficient. It's much faster and much more efficient, as we're going to see in some following examples. Why it's much more efficient? Because mutations, biological mutations, they're purely random. They don't have any intention. While good inventors have thinking, they have knowledge, they can use scientific knowledge or do some experiments with nature and make a directional change. This allows inventions and changes to be better directed towards a plausibly positive goal of improving technology. But at the end, even best possible ideas, even deepest research and understanding of the processes, at the end, they can be accepted or not accepted by the society. And as you understand, most of the biological mutations, or the overwhelming majority of biological mutations, are negative. And in the same way, most of good inventions in general are not used by the society. So it's only some inventions are selected and form a basis for improved technology or for a new level of technological development. The second topic today is major technological revolutions in human history. First of all, technological progress is not continuous. It has significant jumps which are separated by periods of relatively slow development, sometimes stagnation, and sometimes even decline. So far, we had four major jumps, four major technological revolutions. And these are, the first one around 50,000 years ago. It's called the Greatest Leap Forward. Then we had 10,000 years ago, farming revolution, then urban revolution, emergence of large states and civilizations. And finally, another technological revolution that you are very much familiar with is the Industrial Revolution, which started maybe around 250 years ago. It's important for us that technological revolutions change not only technology, they change the whole society. They have a very significant, profound impact on the whole society and its social organization. That's why some technological changes, which might be significant, such as introducing of iron or large-scale introduction of iron, is not seen as technological evolution on the same scale. What we need to note is that each technological revolution, with exception perhaps of the agricultural revolution, is preceded by some change in communications. These are emergence of developed language, arts and abstract thinking around 50,000 years ago, then urbanization, people start to communicate in relatively large cities, and emergence of writing, printing of books and journals, and finally, of course, we have this internet, which completely changed the way we communicate with each other. Because of this, we might expect that this change in communications would follow yet by another technological revolution, which we don't know how exactly it's going to look, but we call it a knowledge revolution, and expected new state of the society would be knowledge society. You can see that each technological revolution results in a different type of a society, as we just mentioned previously. Finally, what I wanted to tell is that you can obviously observe that overall progress, the rate of overall progress is accelerated due to technological discoveries, and which indicates that each new form of society which follows technological evolution has a more efficient evolutionary processes, more efficient and faster evolutionary processes. Let us examine the first technological revolution in human history, which took place around 40,000 years ago. And this revolution is called the Greatest Leap Forward. And indeed, it had a profound influence on human history and further development of human society. Before this revolution, there were many humanoid species, and they competed against each other. They developed biologically, and it was accompanied by significant increase, very rapid in evolutionary terms, increase of the brain size. These species, many of them, were quite successful, especially Homo erectus, which settled all around the Earth, except Americas. They use tools, and it's not a surprise because tools are used even by highest animals and even by some birds. But what is surprising, that such a significant change in human biology, in increase in mental abilities, which reached mental abilities of modern humans, was accompanied by very little technological progress, almost none. There might be some changes, some adjustments, some refinements. It's not that it was completely stagnant, but these changes over a million years were staggeringly small. And finally, around 40,000 years ago, a revolution takes place. And human society becomes very different. It becomes inventive. They have a variety of different, very refined tools, which are shown here. Sculptures, inventions, arts, paintings. When these paintings were discovered in France and Spain, initially most people thought it's a fraud, because they thought that 20, 30, 40,000 years ago, people didn't have abstract thinking sufficient for making such artistic images. They are artistic even according to modern standards. But finally, we now know that these paintings belong to human society, which existed like 30, 40,000 years ago. And they do indicate that humans had abstract thinking, and most likely at this stage, a developed language, which is one of the major tools of abstract thinking. So what this change, what this revolution indicates? It indicates a process of emergence. Before this revolution, we had a biological evolutionary process, which had some cultural elements, but was dominated by genetic evolution. And finally, 40,000 years ago, this evolution changes to cultural development. And as a result of this change, we observe an explosion in creativity, in technological inventiveness, and obviously this cultural evolution is much faster and much more efficient compared to previous genetic evolution. We can see this as emergence of new properties, new systemic properties, and new evolutionary processes. What's interesting that biological structure, at least structure of the brain, was mostly frozen. It did not increase ever since, and in fact, it was slightly reduced. So the evolution that we are interested in, evolution which brings technological discoveries, is a social phenomenon, is a phenomenon of social propagation of information. And presumably it was induced by introduction of a developed language and overall development of communication skills in human society. Okay, the next revolution is farming revolution, or agriculture revolution, which took place approximately 10,000 years ago. And unlike other technological revolutions, it's not related to changes in communications. Most likely, it's related to actually climate change and onset of interglacial period. As you can see, farming started in the Middle East and was propagated to other regions, propagated quite slowly. And because of the slow pace of propagation, there were other independent centers where farming was invented, in China, in Africa, and in America. And this process took thousands of years. even at present, some tribes are still hunter-gatherers. So farming took over the world, but not immediately. Also, its effect on human welfare was not so clear, because it seems that hunter-gatherers overall had a healthier diet and healthier population. So life after introduction of farming did not become easier for humans, but it's quite obvious that farmers could sustain a larger population, and overall farming societies were the winners in competition with hunter-gatherers. The next significant leap forward and big technological change is urban revolution. Urban revolution is a discovery of a new paradigm, and this new technological paradigm allows large groups of people of living together in relative comfort. As you can see, these happened in Mesopotamia, and as a result of urban revolution, first large cities on Earth emerged, and you can see that these cities were quite significant, even according to modern standards. When people start to live together, they communicate, they exchange information, and this results, these new ways of communication result in explosion, in absolutely unrivaled explosion of technological discoveries. Sumerian society can boast so many technological inventions that probably no any other society can. And this includes, first of all, writing, of course. Since that time we have written history of mankind. It started from Sumer. Then arcs, constructions of canals, agriculture, wheels, musical instruments, beer, and many other inventions, arithmetics. If you look at modern society, we still use 60 as a base for some for using time units. Say 1 hour has 60 minutes. It comes from Sumerian society, which existed over 5,000 years ago. So we have a new type of communication, closed city living and writing. And this new type of communications creates opportunities for development of a new generation of technologies. And this type of generation of technologies, urban technologies, they exist in a slightly modified and improved form up until the Industrial Revolution. In order to observe evolution of construction technology, we may examine construction of pyramids, or ziggurats and pyramids in Sumer and Egypt. It's a history of engineering frozen in stone. First of all, there was some evolution of temples and ziggurats, which were public buildings in Sumerian society. They evolve according to social changes in this society. They evolved over many centuries. And this idea of building ziggurats was taken over by Egyptians, who constructed pyramids, and these pyramids were converted into private residences for afterlife of their divine pharaohs. As you can see, first 100 to 200 years after this idea of constructing pyramids was adopted by Egyptians, it was a very fast and very progressive in some way, development of construction technologies. The shape of pyramids change. They build higher and higher pyramids. So it's obviously they did improve construction technology, which was quite amazing because they could move very large stones. But after that, you can see clear signs of stagnation. Clear signs of stagnation. Pyramids become smaller, and it's quite clear that most of the pyramids which are standing today, which are marked by these yellow triangles, are built in early stages of this construction of pyramid period in Egypt. So you can see that technology does not necessarily develop through centuries. It experienced very rapid progress initially, and then a very lengthy period of stagnation or even decline. But the role of Egypt is taking these inventiveness ideas which were created in Sumerian society, taking them on, modifying them, improving, and passing to Greco-Roman world. And from Greco-Roman world, we learned these ideas, and they were transformed in one form or another into the modern society. While artistic and cultural achievements of Greek and Roman worlds are universally admired, they did have some significant technological achievements as well, which worthwhile to be not only mentioned but admired. First of all, just the first mechanical computer, which was invented 160 BC. The Roman roads are very well known, and some of them can be used even today, although they were built 2,000 years ago. Roman Colosseum had the capacity of 60,000-80,000 people, which is quite large even compared to modern stadiums. Rome was a very large city, even according to modern standards. Its population probably reached 1 million people. And in some way, economic and political life in Rome is very similar to what we experience today. I would like to mention a dispute between Boris Johnson, he wasn't a prime minister at that stage yet, and Cambridge professor Mary Beard. Boris Johnson defended Greek culture, and Mary Beard was on the Roman side. Boris Johnson's argument was that of prime importance and originality of Greek culture, which developed philosophy, democracy, arts, and the Romans were just poor imitators of Greek culture. Mary Beard agreed, but she produced some pieces of Roman writing which very clearly indicated that in many respects life in Rome is very similar to what we experience in modern days. And it was very convincing. Ultimately, Boris Johnson lost his argument. So in some way, socially and economically, politically, legally, Roman society is quite similar to what we know today. We still use some legal principles that were engraved in Roman law. At the same time, there is a huge difference. And this difference is primarily due to technology. Roman technology is not even close to what we experience since the time of Industrial Revolution. While Greek and Roman society had impressive technological achievements, overall development of technology was quite slow. And this can be illustrated by evolution of Navy. And you can see that over many thousand years, a few thousand years, inventions in in shipbuilding were not that great. I'm not saying that there were not any inventions. So, for example, we can mention Greek fire, but overall the shape and performance of different Navy ships remained basically similar over many hundred years. This is in contrast with very fast development of European shipbuilding, especially during the times of active exploration of the world. And finally, at the time of Industrial Revolution, introduction of steamboats. So overall, social and economic achievements do not necessarily guarantee speedy technological development. They're important preconditions for technological developments, but they don't guarantee. Roman society was largely dedicated not to technological advances and development. It was consumed with political struggle, with some economic issues, but technological development was not a top priority in Rome. And maybe this was one of the reasons why impressive and sophisticated Roman Empire at some stage collapsed. Another interesting topic I want to mention is development of technology in China. During medieval times, Chinese technology was far ahead of European technology. And many very important inventions were made in China. For example, we should mention compass, paper money, and of course printing books. Blast furnaces are shown here. Printing books started in China long time before books were printed in Europe. It's another fact about China, which is not widely known, that in the 11th, 12th centuries, China was very close to industrial revolution. And one of the indicators is that production of cast iron in China was quite similar to production of cast iron in Great Britain during the first stages of the Industrial Revolution. But this transition to industrial society was approached by China, but nevertheless wasn't achieved. And during following centuries, technology in China and Chinese society in general stagnated, and ultimately were overtaken by very fast development of science and technology in Europe. Now let us examine development of technology in medieval Europe. It might be the case that culturally medieval Europe wasn't a world leader and obviously would yield to the Greco-Roman world, the classical world in cultural achievements. But medieval society was changing, progressing, education, Renaissance. What is important to know that nevertheless, medieval society was quite inventive, and technologically it was noticeable progress during all these centuries. Another point that we need to make is that one of the most important discoveries, which is book printing, which was introduced in the 15th century by Gutenberg, was followed by significant changes in information flows, increase of exchange of information, which subsequently resulted in scientific revolution and then in industrial revolution. It's quite similar to the patterns we might observe in Chinese society. They invented printing books early, and a couple of centuries after that, they approached, although didn't achieve the Industrial Revolution. So the conclusion that we're going to make that technological inventiveness and exchange of information, such as printing books, efficient exchange of information, are important components which predate industrial revolution. Again, we wish to stress increase of speed of technological development as we progress towards higher and higher forms of evolution. One of the first technological revolutions in human society was farming revolution and propagation of farming from the Middle East into Europe took over 3,000 years, quite a lengthy process. Industrial revolution started in Britain and propagated into Central Europe and then into Eastern Europe, and for the whole process took only 50 years. You can see dramatic acceleration of evolutionary processes, and it indicates increased efficiency in exchange of information, of technological information, and overall increase of speed of development of new technologies. Let us try to summarize what the history of technological development tells us. We have a sequence of emerging processes of higher and higher complexity and higher efficiency. Originally, humans were developed through some biological evolutionary processes, and technological development was extremely slow. But once a certain intellectual level was achieved, and what's most important, human developed some cultural ways of exchanging information, another process explosively emerged, and this process brought big cultural changes as well as significant technological development. Now the same happened during industrial revolution. Of course, previous urbanized form of living, they created economic and political and legal and social conditions for technological development. But once we invented a new efficient form of information exchange, which was printing books and scientific journals, at some stage, a very efficient and new form of evolution, technological evolution, emerged. And in its speed and its implication, overtook all previous centuries, not centuries, millennia of human development. Now we are standing in front of possibility of other changes. We have a very significant progress in communications between humans, which is introduction of internet. We can communicate in a way which was unthinkable even 20 years ago. We can expect that these changes in information flows, in ease of accessing information that is unparalleled in human history, can bring some revolutionary changes in technology, speed up of technological progress. We generally tend to call this possible change as a revolution of knowledge, and the state of the society that we might be achieving in some future. It might take some time, it's not immediate, but we call it global knowledge society or knowledge society. Let us consider what such knowledge society might involve. So let us try to examine the trends that we observe in development of technology, science, and human society in general, and see what kind of changes it might bring us in the future. First of all, the first stages of industrial revolution were marked by parallel development of science and technology. It wasn't much of interchange between them. As technological development progressed forward, it's based more and more on science. And these conditions of merging between science and engineering, science and technology become more and more evident. Probably it would be prominent, it will be a prominent feature of knowledge society. Importance of knowledge as different from information. We just previously described that information is not necessarily knowledge, but as we progress towards knowledge society, it is knowledge that represents validated, structured knowledge that we are most interested in. Another feature is that basic knowledge becomes widely available through internet and other means, and cannot give a very significant advantage. Like if you take situation, say 100 years or 200 years ago, then obviously literate people had advantage over people which are illiterate in getting good jobs and being notable members of the society. These days, everyone is literate. So you need to know much more to be competitive. This process is going to proceed further. So just basic knowledge is available to almost everyone. And it cannot bring a significant competitive advantage. What can bring is ability to create new knowledge, is inventiveness, creativity, ability to transform, change ideas, and apply these ideas in a different way. Okay, let's try to summarize the main points. Technological development of mankind wasn't monotonic. It had some leaps, some jumps, revolutions, separated by lengthy periods of technological stagnation and occasional decline. This uneven pace of technological progress is determined by emergence of a sequence of evolutionary processes, and each new evolutionary process appears to be much more efficient and much faster than its predecessors. Technological evolution is an emergent property of cultural, political, and economic evolutions. And at this moment, it's a central element of modern society, which drives forward technological, social, and economic development. And finally, we should or might expect yet another technological revolution. This expected revolution is called the revolution of knowledge, which is likely to lead to so-called knowledge society, where intellect, inventiveness, creativity, ability to create new knowledge would be most important. Okay, there is some additional topic. It's how old is engineering? I think engineering must be as old as human civilization. Somehow, this point, which seems obvious to me, is reflected in relatively few publications. We might try to find some mention of engineering or engineering-related activities in early Sumerian texts. Engineering was very well known in Greco-Roman world, and among Romans and Greeks, engineers were called architectons, which literally means chief craftsman or leading craftsman. Just I want to mention some words of first military engineer. He served with Julius Caesar, and then civil engineer Marcus Vertulius, who wrote the first known book about engineering. The engineer should be equipped with knowledge of many branches of study and varied kinds of learning, for it by his judgment that all work done by the other arts is put to test. This knowledge is the child of practice and theory. I believe these words are as much related to ancient engineers as they are related to engineering profession today. I try to find some mention of engineering in earliest known text, and the earliest known book is Epic of Gilgamesh, which has been translated and very well known in modern world. And I found some places where work of engineers is mentioned with great reverence and respect. I think it's a clear indication that some basic engineering profession already exists during Sumerian times. And the last question I want to answer, which engineering was first, civil or military? During historical ancient times, of course, you know that there were two prominent branches of engineering, civil and military, up until Industrial Revolution, where other types, mechanical, electrical, and other types of engineering emerged. But which one, civil or military engineering, was first? I think we have clear evidence that it was civil engineering which was first. Why? Because in early stages of each development, Sumerian society was collegial and was very peaceful, focusing on peaceful engineering projects. Sumerian society was divided into city-states, and later on conflicts broke between the states, and warfare became more and more common. In response to this, of course, military engineering emerged, and city-states became surrounded by high city walls, as it's shown here. And from now on, military engineering played important role in any civilized society. Okay, that's probably all what I wanted to tell today. Thank you for your attention.